Welcome to EFI Basics Part 12. In this video, we're going to be looking at our main Spark table and modifier maps, as well as an overview of ECU hardware, firmware, and software. We have a lot to learn, so let's get started. Let's start this video off by having a quick overview of our ignition timing table tuning. Now, we're going to have our main Spark table, and this is going to be where our spark calculations are derived from. So this is going to be where we want to fire our spark plug. Now, we're going to have modifier maps from our main spark table to account for things such as air temperature, engine coolant temperature, and starting. And this is going to be the same concept as when we looked in EFI Basics Part 11, where we had our main fuel table, and then we had our modifier maps that modified the injector pulse width. Now, these spark timing tables we're going to be looking at are going to be found in a multitude of different platforms. So whether it's going to be an OEM-based ECU that we're tuning or a race standalone application, we're going to see these same ignition timing tables. So these are going to be very, very key to understanding what to do in controlling our spark timing. So let's have a look at our main spark table so we can see what it's all about and understand how it works. So let's get started by looking at our main spark table. Now, this is going to be where our spark calculations are derived from. So if we look at our table here, we can see that it's a three-dimensional table based on engine RPM and engine load. And our engine load is going to come from our manifold air pressure sensor, or our MAP sensor. Now, the values in the table are expressed in degrees of BTDC, or before top dead center. So if we find a value of 50 degrees BTDC in our spark timing table, that means that we're going to be firing our spark plug 50 degrees on our compression stroke before the piston reaches top dead center. And likewise, if we have a value of 0 degrees, that means that we're firing our spark plug when our piston reaches top dead center on our compression stroke. If we have a negative value in this table, it represents firing our spark plug on the power or combustion stroke. That's going to be late timing. So if we have a value of 50 degrees, that's going to be considered advanced ignition timing. And if we have a value of 0 or negative 10 degrees, that's going to be considered late or retarded ignition timing. Now, if we look at the axes on our table, we're going to see that again, it's engine RPM and engine load. And if we look closer, we can see that we're going to move in small increments of 3 to 500 RPM. We want to make sure that we have the maximum amount of breakpoints that's going to be appropriate for our engine application. We also want to make sure that we have the breakpoints scaled appropriately for the application that we're using the spark timing table on. For example, if we have an engine that's naturally aspirated, we know that we're not going to have higher than 0 psi of positive manifold pressure because the engine isn't using forced induction to achieve higher than that in manifold pressure. So we would scale our load axis about 1 to 2 psi at the most, so we have a little bit of wiggle room in case the engine was able to build a tiny bit of positive manifold pressure from maybe a ram air effect from an intake. Now, the same goes for our engine RPM. If our engine's only going to spin to 7,000 RPM, we would scale our table to a maximum of 7,000 or 7,500 RPM so that we have the maximum amount of breakpoints available on our table so that we have the most amount of data points to be able to calculate our spark timing from. This is going to give us much more accurate spark timing when we want to control the combustion event. Now, if we look at our spark timing table again, and we look at the values in the table, we can see that they vary, and they change from anywhere from negative 10 degrees to 50 degrees. Now, if we look here, this area is going to represent our idle area. So this is going to be where our engine's idling at. If we look here, this is going to represent our cruising or part throttle driving condition. And we're going to be able to increase our spark advance here because our engine load isn't going to be significant enough for spark knock to occur. So we're going to be able to reach that maximum brake torque timing with our spark timing so that we're able to achieve the maximum amount of power and torque and therefore efficiency out of our engine as it's running. Now, if we move up to this point here, we can see that we're at 0 psi on the load axis, and we're going to see that that's going to reduce our spark timing. This is going to represent a zone for a naturally aspirated engine. So if we're at wide open throttle and we're naturally aspirated, we're going to be in this area of the map. Now, if we're supercharged or turbocharged, we're going to look at this section of the map, and this is going to account for the variation in boost pressure or the positive manifold pressure above 0 psi. And we can see as we move up in load, we reduce our spark timing. And that's to control our combustion event because our cylinder pressure and temperature rise, and we want to avoid spark knock. So the last thing I want to touch on here with our spark timing table is that while we're tuning our spark timing values, we always need to keep in the back of our mind that we want to achieve that maximum brake torque timing. However, that may not be possible. So if we're tuning these values and we keep increasing or advancing the value and moving them higher, we may find that we're not able to achieve our maximum brake torque timing because we're getting spark knock. So in that case, we'd have to back off our values. This is going to be more prevalent when we get up in engine load. So if we're at 0 psi or higher, we're going to see we have some of the highest engine load. So we're going to have to reduce our spark timing like we see in this table here. Now, we're going to be covering the concepts and the techniques to tuning the spark timing in EFI Advanced and in the system-specific courses coming up. So looking at the table now, we just need to understand that we want to use this table to control our combustion pressure and temperature to achieve our safe and normal combustion, and also try to achieve our maximum brake torque timing whenever possible. So the next table I want to look at here is our ignition coolant correction table. Now, this table is going to be based on our engine coolant temperature. We're going to find that we have more spark advance that's required when the engine is cold, and that's going to allow for a faster warm-up and more stable operation. And as the engine comes up to normal operating temperature at, say, 180 degrees, we're going to see that our table zeroes out. And if we get our engine in a overheating condition, we're going to want to reduce our spark timing because we're going to want to prevent pre-ignition and knock from occurring. Now, this is a modifier table to our main spark timing table. So for example, if the spark timing table is giving us a value of 30 degrees, and our modifier map was saying let's reduce the ignition timing by 3 degrees, our new spark timing value that we're going to deliver to our spark plug is going to be 27 degrees. So let's next look at our ignition air temp correction map. Now, this is going to allow us to alter our spark timing based on our intake air temp sensor reading. Well, if we have a very hot inlet air temperature or intake air temp sensor reading, we're going to need to reduce our spark timing because we're going to have a more likelihood of pre-ignition and knock occurring. So we're going to utilize this table and we're going to be able to pull spark timing out as our air temp gets hotter and hotter. Now this table is going to be a modifier map to our main spark timing. If we look at our main spark table and at a particular engine load and RPM point, if we found that we were operating at 30 degrees, and this table was showing that we would be pulling out -4 degrees, we'd have a new combined ignition timing value of 26 degrees that we would deliver to our spark plug. And again, we do this to avoid pre-ignition and knock conditions. So the last table we're going to be looking at here is our post-start timing compensation table. Now this table is going to be based on engine coolant temperature and engine runtime. This table is going to be used when we fire off the engine and it immediately runs. We're going to start the table at our 0 time here, and then we're going to taper out the ignition timing to essentially 0 once the engine runs for 5 or 10 seconds. Now we want to utilize more spark advance when we fire off the engine to help improve idle stability. At colder engine temperatures, we're going to find we're going to need a bit more advance than a warmer engine to help increase that idle stability. Now, if we look at the table again, it zeroes out to no ignition timing added at the 15-20 second range here. And that's because we don't want to add any more ignition timing to our main spark timing table. We want to make sure that we zero it out and then we're riding on the values from that main spark timing table. Now, this table is going to be a modifier table, so it's going to add or subtract, and in this case, add or add advance to whatever the value is from our main spark timing table. And it is a conditional map, meaning it's only going to be used for that first 0 to 5 to 10 second period of when the engine fires off and starts to run. So in this next part of the video, I want to talk about ECU hardware, firmware, and software. When we open up our ECU and we look inside, we're going to see all kinds of different hardware on the ECU board. We're going to see injector drivers, ignition coil drivers, we're going to see capacitors, resistors, transistors, memory chips. So we're going to see a magnitude of different kind of circuitry to achieve the outputs that we desire or to read the sensor data coming into the ECU. Now, in order to control this hardware, we have to use both firmware and software. Now, the ECU firmware is going to be what we can communicate with our software, and it communicates and it transcribes the software language into language that the ECU hardware can understand so that we can achieve our desired results. So for example, in our software, which will have our graphical interface that we're going to make our changes in, if we command more injector pulse output in our software side of things, it's going to transcribe that into a language that the ECU hardware understands so that it controls the injector driver to increase the pulse width to our injector to deliver more fuel. Now, over the lifespan of an ECU, we're going to have software updates to allow more features or more data logging, or there's going to be updates that are associated with any electronic device such as your phone. So in order to run these new software updates, we would have to do a firmware update as well. And that's going to allow that new software programming language to be able to send to the ECU hardware so that we can properly control the ECU hardware. Now, when we do a software update, we typically will do a firmware update. And when we go into the system-specific videos, we're going to be showing how to do the firmware updates and how to do the software updates so we understand how that process works.